Okay, so let's talk about how to graph data when you need to do that. So I essentially break it down into 5 steps when I need to make a graph. So first, what is the purpose of your figure? What are you trying to tell your audience? What question are you trying to answer? Second, you need to identify what's going to go on your x-axis, which should be your independent variable, and what will go on your y-axis, which should be your dependent variable. From that, that'll tell you which type of graph is appropriate. Usually we're choosing between a bar chart or a scatter plot. Those are the two most common types of graphs. Then you need to choose which data you're going to graph. You don't always have to graph all of your data. And then think about if you need to normalize or combine your data or analyze it in any way to make the graph better. All right, so let's go through a couple of examples where we do these steps. All right, let's say here we did an experiment where we set up 3 different tanks where the water was at different temperatures, 60, 70, or 80 degrees Fahrenheit. And then we measured, we put in a bunch of eggs and let them grow up to adult fish, and we measured how many were male, how many of the fish survived, and how many of them were dead. All right, so let's go through our questions. So let's say that for this figure, what I want to show is whether temperature affects the survival of fish. All right, that's the question that I want to address with this figure. All right, so for that graph, my x-axis or independent variable would be temperature. All right, that's the thing I'm adjusting, and my y-axis or dependent variable will be fish survival, what I'm measuring. All right, now how to identify the appropriate type of graph? That really is all dependent upon your x-axis, right? If your x-axis is quantitative, it's numerical data, right, that relates to each other, you're going to choose a scatter plot. If it's categorical, so not numerical, that's going to force you to use a bar chart. So here, my x-axis is temperature. That's numerical, right? I've got 60, 70, 80. So I'm going to choose a scatter plot for this one. Then I'm going to select the data to graph and think about how to normalize or combine my data. All right, so I've gone through steps 1 through 3 and made my choices. Steps 4 and 5 are the more difficult options. So let's take a look at my graph after I've just gone through steps 1 through 3 and graphed everything. All right, so here I've got temperature on my x-axis, number of fish on the y-axis, and I've graphed all of my data, male, surviving, and dead, okay? And I've done it as a scatter plot. So this is an appropriate graph, but it really has more information than I need in it, right? I don't really care about how many male fish there are. The question that I want my graph to show is whether temperature affects survival of fish. Okay, so we can clean up this graph a little bit by eliminating some of the data. Now we're just graphing the survival of my fish, and it's much easier to take a quick look at this and get an answer to my question of whether or not temperature affects survival of fish. Here it's suggesting that maybe 70 degrees is the optimal temperature, and that 60 might be a little cold and 80 might be a little hot to support fish survival. All right, let's go through another example. So here I've tried 3 different brands of fish food to feed my fish, Fish Delight, Shrimptastic, and Guppy Food. And for each of those, I've set up 3 tanks. I've put in 50 fish for the Fish Delight tanks, and I've measured how many survived and how many didn't survive. For Shrimptastic, I did 25 fish in each tank, and for Guppy Food, I put 50 fish in each tank, and again measured survival for all of them. All right, so let's go through our questions. Identify the purpose of my figure. Here I want to say which food is the healthiest to support fish survival, right? So what's going to be my independent variable? That's going to be type of fish food. My dependent variable or y-axis will be survival. Okay, so which type of graph, bar chart or scatter? Well, remember it depends on your x-axis, which here is fish food. That's not quantitative, it's not numerical, right? So I'm going to have to use a bar chart. All right, so let's look at what my graph looks like. Okay, so on my x-axis, I've got my fish brands, and I've graphed the number of surviving fish here. Okay, so this is a good start. Let's clean it up a little bit. First, let's consider if we need to normalize our data. Right, so remember that for Fish Delight and Guppy Food, I had 50 fish in each tank, but for Shrimptastic, I only had 25 fish in each tank. So it's really not quite fair to be graphing the number of surviving fish. that's hard to compare because Shrimptastic can only have a maximum of 25 surviving, right? So first I should convert this data to percent survival. All right, so now I've changed my data to percent surviving fish so that Shrimptastic is now comparable to my other brands, and it's really a fair comparison now. Okay, how else can I clean this data up? Well, it's kind of busy, right, with all my replicates shown, so why don't I take the average of these replicates to see on average how many fish survive with each of my 3 food brands. All right, so now we've got a much easier graph to look at, and you can see my axis is changing, which is why the graph looks so different. But it's much easier now to just compare Fish Delight, Shrimptastic, and Guppy Food. But there's one more step we want to take. Whenever you average data together, you want to maintain the information about how much variability there was in that data. So going back to here, for example, Fish Delight gives a very consistent result of around, I don't know, 84% survival. Whereas Guppy Food might average around 84% as well, but there's a lot of variability here, right? Some of my tanks only 70% survived. So I don't want to lose that information, and the way we do that is by adding error bars that represent the standard deviation of the data that you average. And you can see Fish Delight has a very small standard deviation because the data was very consistent. Guppy Food has a larger standard deviation because that data had more variation in it. Okay, and that's important to know. If I want to guarantee at least 80% survival, I should pick Fish Delight. If I want to potentially get 100% survival in some of my tanks, but very poor survival in other tanks, maybe I'd choose Guppy Food instead. All right, so that's what there is to making graphs. So remember the 5 steps. Identify the purpose of your figure, pick your X and Y axes, select the appropriate type of graph, scatter or bar chart, choose the data to graph, and consider whether you need to normalize that data, so changing to percent survival or etc., and whether you need to combine replicates for that data. And that's it.